wondrous things, but other than that, it's all good, right?
Yeah.
Right, should I share my screen then? And
we just go a couple of screen, and then we will hand it over to you,
Yep,
Bob,
great.
immediately after that. Just want to start. Okay, perfect. Maybe in a minute or so. Just intro slides, and then we will hand it over to you
Right.
immediately after that.
Yep.
Exciting. This is the first time, Sandeep, I think I'm seeing this, like this many people join, like I'm super excited about this. We have like around, just to let you know, 110 people registered on Meetup because we have other areas. So that was the maximum number of people who really signed up for this particular session. So.
Right, yeah. And sort of, I assume that it sort of typically is about a 50% kind of drop off between the kind of sign up and turn up. Well, that's what actually we get for sort of free events, you know.
Okay.
All right.
Yep.
Yep. Awesome. Great. Thanks everyone for joining again. This is exciting. We have Bob here and Sandeep, and the title is in front of you, replacing your ADF pipelines with notebooks in Fabric. I personally never used ADF pipelines, but I'm in the Fabric world, so this is something exciting I'm going to see because some of my clients probably using and would like to switch over to notebooks. So looking forward to this session. And where did it go? Where's the next one? Next slide. Next slide. Next slide. Quickly about us. My name is Parvinder Chana. I'm in Vancouver, and I run my own consulting and all things Power BI and Fabric now, of course. I have a YouTube channel. I'm more focused on DAX and all that kind of stuff. And Sandeep is partner in crime. We both are organizing this user group. I will let Sandeep introduce himself.
Yep. Yeah. So Sandeep, I write a blog, and I'm also a data platform VP. Parv and I, we've been doing this for almost a year now. So really glad that all of you took time to join us. And special thanks to Bob. I've been following him on the social media, all of his blogs and everything. Learned a lot from him. So really excited to see what he has to share with us. So thank you, Bob, again.
Awesome. Quickly, again, after this slide, we're going to hand it over to Bob. So we are recording this, and it will be shared afterwards, most likely within 24 hours. As soon as Teams give it to me, I immediately put it on and share the link. Please keep yourself muted during this presentation. Again, Bob said at the start of this, if you guys have a question, please interrupt him, raise your hand, and you are... Sandeep and I will be monitoring the chat, but you are open to come to unmute yourself. And if you're putting your question in the chat, just prefix with the Q so that we know it's a question. And Bob, it's all yours now. Thank you.
Awesome. Okay. So just going to, hopefully everyone can see that. And I'll just
yes,
the Teams window out of the way, so it's full screen on the recording. Okay, so yeah, so you know the sort of topic. What we're looking at is replacing your ADF pipelines with notebooks in kind of Fabrics. Now, it's a lot more than replacing your ADF pipelines, because you could also replace your Fabric pipelines, right? It's basically, how do we move from pipeline-centric to notebook-centric in terms of architecture, right? For those of you who don't know me, my name is Bob. I've been around the sort of data engineering sector a long time, like over 30 years. I think I've been an MVP for 18 years. I'm what used to be called a SQL Server certified architect, a certified master. I did the analysis services Maestro senior thing, and the Power BI fast kind of track architecture. So anything that involves large scale enterprise architecture on the Microsoft platform, I've probably done. What's most kind of relevant here is I work with a Fabric featured partner in Ireland where we help customers implement Fabric solutions. So this talk is really about our commercial experiences implementing Fabric and what we've done on our journey to move from lots and lots of pipelines to not so many pipelines, and maybe why, right? So this is the agenda. I am focusing on data warehouse architecture. So Fabric is a very wide field. You can use it for data science, exploratory work, experiments, but I'm really talking about the classical data warehouse, going from bronze, silver, gold, building a star schema at the end, having a one lake to store any raw data type stuff. So what architecture am I assuming that you have? And then we'll kind of recap on what are pipelines, why do we hate them so much? And most of the talk is really on how do we replace them, right, on a like for like, and maybe improved architecture as well, right? So let's dive in, right? I'm going to assume that you're building a solution that looks roughly like this, or this is what we build, right? Typically you have 3 zones of data. I hate medallion architecture, by the way, or just the concept of people naming stuff bronze, kind of silver and gold. I prefer sort of calling things like landing, staging, star schema. It works sort of better for me, right? But anyway, there's 2 main types of architecture that we see, right? One is what we call an imperative architecture. And in here, you want to ingest a file, you write a pipeline, right? The pipeline has the file name, it brings it to the source, it could be using the copy activity, you kind of run it and it works. When you want to do another one, you copy that pipeline and you change it a bit, or you have a golden sort of template that you start from. And when I first started designing data warehouses in SSIS in 2005, this is exactly how we did it, right? Every developer cranked up a new SSIS package, right? And every requirement potentially done by a different developer. When you want to bring your unstructured data into the structured world, so say for example a lake house, a delta table, you write another pipeline, right? And so forth, right? Now you don't have to only use pipelines in Fabric, or indeed if you're using Synapse, there's kind of Spark is available there, so you could start to use kind of notebooks at this point as well. Now pipelines don't generally do transform. So we talk about ETL. Pipelines for me are big at the ingest stage and the E part of ETL, right? But not so much at the transform stage. They're really transport phases. They're really good at moving data and orchestration and sequencing activities, but not so much for transforming, right? So for most people, when they're transforming to build a star schema, so doing the semantic sort of modeling of aggregating, merging, joining, reshaping, generally people are going to be using another technology. Could be notebooks with Spark SQL, could be T-SQL, or God forbid, it could be a data flow, right? Now, if we do a review of a system, the first thing that we do is count the number of artifacts. And if we start to see those sort of numbers like, 1,000 stored procs, I mean, we've got sort of customers with thousands of pipelines, right? It's generally a sign they're probably using an imperative architecture, right? And the same goes for orchestration, right? Within pipelines, on small projects, you can do orchestration by having a pipeline shape to say, run that pipeline, then run that pipeline. If that one works, then run that pipeline. If it fails, then run that pipeline, and so forth. Works great for small systems. When you work on systems of thousands of activities, it's a really bad idea, right? But for small systems, it's kind of a good idea. Another thing to be careful of is when you design, there's generally standard functions like login, lineage, error handling. As an architect, I call this fat, right? It's stuff that you have to do, but it's not the juicy stuff, right? And you don't want developers putting these in to every single template. You generally want those to work at higher level, right? So declarative architecture, or what a lot of people are calling a template based architecture, then exactly the same zones that you're really going through, right? So there might be 3 zones of data, but you'll have a framework, right? So we have a framework that we have one in SSIS, we have one in ADF, we have one in Synapse, and we have one in Fabric. And they're all fairly similar in concept. You have a metadata database that describes all of your pipelines or your units of work. Could be a list of tables that need to be brought in from an Oracle database, a list of files from an SFTP source, a list of APIs that have to be called. Then there'd be a common way of implementing the shared features that don't have to go into each pipeline, right? Some way of doing dynamic orchestration. So there'd be a list of sequence activities in a data table and some way to sort of dynamically launch them. And the big one is there'd be a template library of reusable components, be that pipelines, notebooks. I'm not a fan of sort of data flows, but certainly stored procedures and stuff like that. Now, the reason I'm not a fan of data flows, either Gen 1 or Gen 2, is they tend to be imperative, where they work for one function. So they're great for experiments, but the reusability of them to an enterprise scale is tricky, right? You couldn't, say, for example, have 20 different tables flowing through one Gen 2 sort of data flow, right? The schema is kind of part of the M code, right? So now you can write some very fancy M code to try and abstract it, but that's not generally done, right? So the assumption is that there's some sort of template library that has all of your pipelines, and you want to either move that to Fabric, or you're starting from scratch and thinking, should I use pipelines or should I use kind of notebooks, right? So this is the starting point, right? And indeed, just on screen here then, this is a data factory with this type of framework in it, right? So we have a library folder that has all of the pipelines, and you see I've split them between ingest, extract, export, all of the different phases that you might have in a data warehouse. So if we want to get a file in from an SFTP location, we'll use the copy SFTP. We'll put in all the parameters like the host name and so forth. It won't actually put the password in there, but it'll have the kind of secret name, which will get passed up. One of the big difference between ADF and Fabric is ADF has the concept of a link service, right? So here you would register a SFTP endpoint, and one of the things that ADF does superior at the moment is parameterization. So you just create one single link service, and that can handle any SFTP server, because the host, the port, the username will be passed as a parameter, and it automatically knows that if you get this kind of password, look it up in Key Vault and bring me the password back. So it's got Key Vault integration into the connection system, where generally, if you go to Fabric and look at the way that connections work, you're going to be using the Power BI old style of connections, and it's a mess, right? You have one connection per endpoint typically, right? So from an architectural perspective, there's no doubt Fabric connections are worse than ADF connections, right? But the team is working on it, right? They're working on better parameterization and improving that, right? So not everything is better in the Fabric world, and I would say that how connections are made is certainly something that's not so, right? So what we did is we took this ADF here. So if I just cancel that, go back to the pipelines, and then within Fabric, then this would look exactly the same. We have a DWA for the framework. So you see that in the ADF, we had a DWA folder, and then we had a library with all the templates. In Fabric, we have the kind of DWA and a library for all of the templates. In this case, though, most of the templates you'll notice are now notebooks. We still have some kind of pipelines. If we go to extract, you'll see that most of the extracts are now kind of notebooks. There's one here that's Parquet, and sometimes we go crazy, and we've stopped actually doing this now, but you can actually have the same object name, exactly the same, but just with a different implementation. This is pretty cool at first, because I could say extract Parquet, and in a metadata, I could flip between use a notebook or use a pipeline. so I can make that kind of choice at runtime, which is quite cool. But it confused the hell out of people having the fact that the names in Fabric aren't actually unique. So we made a decision to not name things with the same name, right? But it can be done, as you see, right? So why do we need pipelines, right? So there's functions that they do on screen here typically, right? The big ones are orchestration and transport, right? Say, for example, I want to run a trigger at 2 o'clock in the morning. I'm generally going to have a pipeline with that as a schedule, right? And that the pipeline might not actually be doing any work itself. It could be calling other things which have dependencies, right? So orchestration is a big thing. And as I said, those transport phases, right? The copy activity is the Swiss Army knife, right, of ADF and Fabric kind of pipelines. Moving data from A to B is really what the copy activity is for, and it does simplify that process a lot, right? Generally, pipelines don't really do transforms, right? If you're strongly reshaping your kind of data, you're probably going to be using one of the technologies on the right side of the screen. I doubt you're going to be using pipelines. There's some degree of reshaping as JSON that can try and do while it's reading, but it's not. I don't see a lot of projects doing heavy transforms in pipelines. It's really the bits in red, right? The same goes for loading star schemas. If you've done a transform to spit your dimension or your fact out as a temporary table in a silver layer, say, you could use a pipeline to then load that into the gold layer. But typically, most people use Spark SQL or T-SQL for that type of activity anyway. The other bits where you absolutely need it, and this is saying in Fabric, there's a big thing, private connectivity. A pipeline is the only way that you can get a connection to use the integration runtime, right? Well, except for Dataflow Gen 2, right? But it's one of the major limitations of Notebook is they tend to have a public IP, so they're fantastic for cloud-based sources or for interacting with the OneLake. If you've got an on-premise Oracle database, unless you're configured to use a private endpoint, so the whole of your Fabric is on a private IP, it's not going to work. So sometimes you just use a pipeline to get the kind of data into Fabric, and once in OneLake, Notebooks can sort of take over from there, right? Okay, selling points, yeah. Low code, that kind of drag and drop, right? So for self-service type of systems, it's very attractive. There's a lot of connectors out of the box, right? So if you're integrating to Salesforce, HubSpot, I just did a project in ADF where we were connecting to Snowflake, and it was pretty cool. You just drag a couple of shapes on, here's a list of all your Snowflake tables, bang in a SQL statement, and bop. And if you've got kind of metadata-based kind of systems, you can then put all the tables that you want in a metadata table and fully automate it, right? Monitoring and login is relatively mature. Like Fabric has front and center, it's got a monitoring hub, and also ADF has similar monitoring, and people are getting used to how that works and how they drill down to find failures. But the big thing is they're high. So the big selling point for ADF pipelines over SSIS is the parameterization, right? Building of metadata systems. It's very hard to build a metadata-based kind of system on SSIS because the data flow in SSIS is a hard-coded pipeline, right? So its reusability was very low. They fixed that in ADF pipelines, and they fixed that in Fabric pipelines. So for metadata systems, they're very good, right? So why not build everything in a pipeline, right? Like, why do we hate them, right? So there's a sense that and I've got a sense that kind of Sandeep isn't a fan either, right? Why, right? These are the main points that I have is the weight tax, right? With a notebook, there is a spin up time, right? So if you're using a starter pool, and we pretty much always use a starter pool because we're not waiting 3 minutes, right? it's about 6 kind of seconds is your overhead, right? But once it's spun up and you got your libraries and stuff, everything is synchronously fast. So you don't have a wait tax, you know, I want to do a for loop, go away for 10 seconds and come back. It works exact same as any Python code does, right? So your performance and experience is much better in notebooks with that less wait tax, right? If you've got a pipeline with lots of activities, you're paying a cost per activity, and some activities have a horrendous wait tax. The one that I hate most is the lookup shape, the shape that calls a stored procedure or a SQL Server statement to return something as simple as a scalar value. So say, for example, you had a watermark table and you were said, for this table, give me the max value, right? The minimum execution time in ADF is 14 seconds, right? Whereas the query execution time is 100 milliseconds, right? So you're like, the sort of percentage overhead is absolutely astronomical, right? Now, I chat to folks on the product team, and the reasons for that is basically to do with the queuing architecture. That when you want to return something, it's got to get one node to execute it and another node to return the value, and it's got to return it by use of message queuing, which has all this wait time. But as a result, calling a function and getting something back is absolutely horrendous, right? When Fabric first came out, pipelines were a lot more limited than they are now. So I put it that it felt like a version 0.1, right? But it's improved over the last year. So I'm now going to be a little bit fairer and call it a 0.3 or a 0.5. Is it up to where ADF was? Possibly not, right? So if you're only working on a project that just needs pipelines and you're not using any other feature in kind of Fabric, which is pretty rare, I think, ADF is possibly going to give you a superior experience, right? Now, obviously, over time, all the R&D is going into Fabric, right? So maybe it will overtake it, right? There is less connectors in Fabric. Now it's improving. The last time I counted, so just before this talk, I recounted, and there's 71 connectors available in Fabric. I did this talk about 4 months ago, and there was 47, right? So it is expanding, but ADF has more connectors. So for example, I noticed if you work with HubSpot, there is a connector in ADF, but there's no connector in Fabric. So depending on what you're working on, you could find the connectors in ADF, but not in Fabric, right? The big thing for us is the rise of software as a service, right? In the old days, so I've been developing systems for 30 years, right? 20 years ago, everything came in by flat file or database, or if you were really unlucky, XML, right? But 90% of your work when you're building a data warehouse was reading from the database of the operational sources, be that Oracle, DB2, SQL Server. Nowadays, customers are jumping to software as a service, right? So when you're bringing your data in, you're using more and more web APIs. Some of them have a connector, other ones just actually give you an API call and a bit of sample Python code. And what you'll find is pipelines are not very good at doing web API calls. And we'll show some examples. They do the basics, but you very like skiing down a mountain, you very quickly fall off the path, right? And they get exponentially more complex. If you want to do something like recursion, you know, I want to call an API, and for every line in that API, call another API. It's going to get more and more complex and slower because of the wait tax is one thing, and it just breaks the limits of the low code, right? Now, there are bugs in Fabric in some of the activities. For example, if you're using the Lakehouse with schemas, and you generate a Parquet file, which is made in a certain way, like there's some rows, there's some columns are blank, the table gets corrupted. So we filed various bugs and stuff like that, but we just gave up using the copy activity for those type of things, waiting for Microsoft to fix the bugs, right? So that's the why we don't lock it. For me, it boils down to 2 words: performance and extensibility, being able to do stuff that's non-standard easy, extensibility, being able to do things quickly, and not only quickly from how fast it runs in total, but how quickly the developer experience is. So I'm not continually hitting that refresh button on a pipeline and just drinking a cup of tea, right? That for me is what's turned me off pipelines. Now, I still use them. So how would we replace pipelines, right? So I'll talk about the different stages of a data warehouse. So the first stage is the ingest, right? I've got data outside of one lake or ASDL if you're on a sort of ADF, and I want to bring it into, just land it in a raw, unstructured format, right? And very common, we skip the ingest phase now because we're like, well, if the file has no value in being archived, we just bring it straight into a lakehouse structured table, which we call an extract, right? But if you do need an ingest to park it, this is a sample shape that we had in our old ADF platform, which basically copied a blob, where someone had landed files like flat files on a blob store, and we need to copy them down, right? So the shape would just have the copy activity. It would be highly parameterized, so it's reusable. To do that exact same shape in a notebook, so when I ran this for just a small set of files, AdventureWorks, I think it was 15 seconds, and this is bringing 7 small kind of CSV files of a couple of 100K max, right? So not sort of gigabytes, right? So you're like, well, that's not bad, but if I copied 100K on my computer and it took 15 kind of seconds, I'd be smashing my computer on the floor, right? So, you know, it's just, it's not as fast as I'd like it, right? Within Fabric, interesting enough, we did the exact same workload, AdventureWorks files, and it was 28 seconds in Fabric. So it was quite a bit slower than it was on the ADF. And I ran it a few times, like it wasn't like a cold warm thing, right? So sometimes we do find Fabric notebooks run a little bit slower. I don't know why that is, and I'm sure it depends on the workload and stuff like that, right? But it's still, to write that same thing in notebook is then this type of coding. So what you'll do is you'll have a parameter block at the top, and sometimes it will take a wildcard, especially if you're using Spark and there's lots of files being loaded into the same table. It's really what Spark is really good at, because it's a scale out solution that runs jobs. If you can get one job to do lots of files, then that's fantastic. More often than not, if you get 20 files, it's each file is going into a different table. Spark's not so good at that, right? It's kind of going to be 20 jobs, right? Anyway, you can see that this one line of code that does a copy was 3 seconds. So we went from 28 seconds to 3 seconds, right? So now it's only a small file, and as you get larger and larger, but a lot of our projects are doing a large number of small pieces of work, right? When we're building enterprise data warehouse that has 10,000 tables, most tables are piddly. It's only a couple of tables that are massive generally. So this type of performance increase is well accepted. Now there is, within kind of notebooks, you can use a fast copy, which uses basically the AZ copy API. So we're used to Storage Explorer. It's a multi-threaded copying algorithm, which is faster again, but this set of files is so small that it doesn't make that much difference. So what I did is I got the New York taxi data set. I got a Parquet file that's 200 million rows. I was like, okay, it's not a billion, but it's, you know, it's more like a medium size of data that you might actually work with. And actually the copy activity wasn't bad. So in Fabric, the copy activity was 48 seconds, and this was basically 2/3 of a gigabyte on disk, right? When we do that in a notebook, you'll see the copy time was 6 seconds, right? So it went from 48 seconds to 6. But then when we use the fast copy, the multi-threaded nature can suddenly speed it up a bit more, and we got a 3-second execution, right? One of the big selling points for notebooks when you're doing file-based work is this is amazing. You've got the move command, right? So you can do a logical move, right? One of the most frustrating things for me coming from an ADF background, there was no move command. So if you wanted to, say for example, you had extracted files into a staging area, and after you had extracted them, you're like, right, I want to move them into an archive area or into a raw area. The only way in ADF of doing that is a copy activity followed by a delete activity. And don't forget that each activity has between a 3 and 6 second wait tax. So the delete activity has a big wait tax on it as well, right? But what that then meant is if you were dealing with files that were tens and hundreds of gigabytes on the shared integration runtime, you pay for the for a number of compute units in ADF, as opposed to how much data has moved. So just to archive saying, we were getting customers with bills for 500 or 600 euro per month, right, for just archiving. So what we actually did in ADF is we actually found the API, the REST API for ASDL, the old version of Data Lake, does support a move. It's just the pipeline team, because it's low code, didn't actually put a button to implement it. So we actually wrote an Azure function that called the REST API that could actually do a move. So in ADF, we could actually do a move, right? But if you're just using basic stuff, there's no way to move. In Fabric, your notebooks have that for you. Fantastic, right? So that's anything that's kind of dealing with copying files around, you'll find is really easy in a notebook. And if you're used to sort of DOS command line, kind of robocopy and stuff like that, it's very trivial, easy to sort of parameterize to get a reusable notebook that becomes part of your library templates that you use there. Okay, REST APIs, right? Here's an example of a REST API call in ADF, right? This is the most simple, where you might make one call to get a bearer token, and you might pass as part of that call a client ID, a client secret, an API key. If you're doing any OpenAI work or GenAI work, there's going to be a lot of API calls that need authentication. So generally, the standard is you get bearer token, you make a second call and inject the bearer token into the header of the API call, and you get your results back. This is actually using the Power BI API to get a list of reports back. Takes it, interesting enough, it takes 18 seconds there. The equivalent notebook to do that is this type of code here. You can see we have one post request where in the request body, I put the client ID, the client secret, and there's a little bit of value added code. So talk about the extensibility, right? In this Python code here, the password is passed in plain text because there wasn't a key vault kind of shape there, right? So here we can use MS Spark utils to use key vault to get the password at a just-in-time secure basis. So we can follow secure coding practices, whereas the ADF pipeline didn't actually have that when we converted it. It was plain text, right? This then does exactly the same, and I can get the kind of JSON, but the execution time for this is 1 second as opposed to 18 seconds, right? Now, obviously, I've got to spin up my Spark kind of cluster, but I'm paying that cost once, and if I can run lots of notebooks, it's not going to be as much, right? Now, Fabric then has other things that do your wrappers for API. So here, because this was a Power BI API, there's actually there's a semantic link library where you can call the Fabric REST client, and it will do all the authentication for you by using the authentication token that that kind of Fabric has. So anytime that you're calling Graph API or Power BI API, you don't necessarily need a service principal anymore. It can just authenticate itself, right? So here, that same thing is now reduced to only 3 lines of code, right? Now, you can go a bit further, because in Fabric, they found the Power BI APIs, people didn't like working with these because they have to understand the namespace of the API and inject kind of the workspace ID and kind of stuff like that. So they shortened it again with the semantic link library. That whole API work can now just be a 1-line call, right? Now, bearing in mind, that the semantic link is a wrapper, and the wrapper has an overhead. So here we've converted it in to a data frame, displayed it, and got a wrapper. But from a programming point of view, it's only one line of code now. But look at the execution time. 772 milliseconds, whereas when I just called the raw REST kind of URL, it was 279 milliseconds. So using a wrapper does have a cost, but it's convenience versus performance, right? SFTP. Here's an example of a shape that we had in an old ADF environment that dealt with SFTP. So we had flat files on SFTP servers. We needed to get them into one lake so we can put them in a landing area so we could extract them, right? So we had a copy activity where the source would be the SFTP linked service. The sink would be the sort of ASDL, which would now be a one lake in Fabric. And there was a little bit extra work to do we want to delete the file after we download it or not, because on some of them it was transactional. They put the file up, we download it, and we delete it as soon as we get a two-phase commit that it has been downloaded. Other ones, it's read-only, and you just kind of download every day, and they do the deletion. In notebooks, then, Spark in Fabric has a massive list of libraries that come pre-installed. There's a lot of open source libraries, and one of them is the Paramiko library here. And this does all of your SFTP stuff, right? And this then means that you can pretty much do a lot of SFTP stuff in one-line calls. So I want to get a list of all the files on the SFTP server. I call listdir. I can loop through the files, have a wildcard, and then say if there's a match, download it. And this then will, now I'm actually going to put it on the filing system, but some of our newer systems actually read the file into RAM, convert it into a data frame, and then write it direct into the structured area of the one lake, right? So extensibility, you can start to get the notebooks to do more and more work if you deem it necessary. Case in point, I only found out about a year ago, as well as SFTP, there's another standard that IBM invented called FTPS, right? I was like, is that a spelling mistake? No, it's similar, but what happens with FTPS is the server is supposed to send an acknowledgement back after authentication to be like, yeah, this particular flavor of the server a customer had didn't actually do that. So the connector in ADF just crashed. When we used a notebook, we could go to the source code, take out the line of code that waited for a response, and then it worked, right? So you can fix your own bugs and extend it to do stuff beyond what the low code environment can. So that's an example of SFTP, right? Converting Parquet to what? So if you've got a Parquet file, right? So sometimes, and we don't find this happens a lot, generally customers don't actually give us Parquet files, but in the future, more and more people are using it. Instead of putting a zip file inside a CSV inside a zip file, a Parquet file makes a lot more sense, right? So here we've got a notebook that takes a Parquet file, converts it into Delta, so it can be actually mounted in a lakehouse as a first class kind of table, can be queried, right? And this is the New York taxi that had kind of 200 million rows, and you can see it took it 2 minutes, right? So the pipeline takes 2 minutes, a bit of click and drag, and you can do that, right? Now, the equivalent code to do that in a notebook is basically here, right? So you can see here that took it 1 minute and 19 seconds, right? One of the cool things that you can do in Spark is you have a little bit more control. So one of the things, I don't know if everyone's heard of Vorder. Oh, I see some great questions there, so I might actually stop on some of those. Is is everyone familiar with the concept of V-order? If you're not, just sort of put up what the hell is this in the chat, and I'll kind of go into it, right? Does everyone know what V-order is or not so? Yeah, or like a thumbs up. Okay, so what the V-order is when you write a Delta file in kind of Fabric, it's a column store, right? And the open source implementation has a degree of compression in it, right? In Power BI, there's also the concept of a column store that has compression, but the compression in Power BI with the VertiPaq engine is superior, right? It does extra compression, extra stuff that makes analytics fast, right? So the V-order puts similar compression on Delta files as VertiPaq had in Power BI and analysis kind of services, which is what lets you put Power BI direct on top of one lake for the direct lake feature, right? So it's extra compression, makes it faster. The problem is if you're writing, it makes it slower to write. So for your bronze layer, where you're only putting something into staging and then only reading it out as part of your ETL process, V-order might not add a lot of benefit for you. So you can see in Spark, we can, when we write the Delta file, we can decide to turn off the V-order for that one file, or for the whole Spark session, we can turn off kind of V-order. And then it finished, instead of 1 minute 19, did it in 1 minute 2 seconds, right? So you can save off a bit of time. Great question about as Z-order is then additional compression on top of the Z-order, on top of the V-order. What I don't understand is if there's a magic command to turn off Z-order as well as kind of V-order. So V-order and Z-order are two types of compression. Z-order is more to do with, do you remember the old days of building column stores in a data warehouse? When you built the column store, you would put an order by, so that the way that column stores work, if your kind of data is ordered, it's compressed even more, right? Because it's not in as many kind of segments. So Z-order gives that degree of optimization by ordering one of the columns, and usually you can get it to pick which column or override that, right? Now, I haven't got the commands to actually enforce kind of Z-order to be a particular column, right? But it's an additional form that's not as big as V-order, basically, right? So that's that. Great question on cost there. So that was 1 minute 2, which this gives us a good segue onto cost, right? One of the big penalties of Spark, right? So here I'm using Spark, right? When you spin up Spark, if you used, can
we,
yeah,
because you're taking questions, so there are a couple of questions that were asked. If you don't mind, maybe we can cover that. So one is related to cost. So I guess you'll cover that in your session or next section. But there is another question that was asked by Bobby about where do you, for your metadata, where do you save your metadata table? Is it in the lakehouse? Because he thinks it's, in his experience, it's slow, whereas the SQL DB is kind of more CU intensive. So where do you do that? How do you do that?
Yeah, let's field actually both of those kind of questions. And I see that Sandeep has a blog on the V-order. I'm hoping you're kind of writing a blog on the Z-order as well, right? Yeah, so let's deal with cost and metadata storage, right? Cost, right? One of the big problems for me with Spark, right, is the fact that when you spin up a starter pool, right, it's 8 vCores, right, for the controller node and 8 vCores for the worker node. And that assumes it's only a one node, right? When you pay for your computer units, you get 2 vCores per kind of CU, right? So by default, it will try and consume 8 CUs, right? Now, because of the bursting effect, you can run Spark on lower ones like a 2 and a 4 kind of CU, but they do consume 16 cores, which is a lot if you're doing a small work. So think about these files at a few hundred K, right? So Spark is expensive, and Microsoft do let you configure smaller pools, but then there's limitations like they don't get the fast kind of spin up time and stuff like that. So there's roadmap for Microsoft to improve things for small people. The other way is people are looking at other engines. So if you're doing very small pieces of work, Spark could be a very big hammer, right? But it's a very standard hammer, like it's well documented, people have skills in Spark. So I was chatting with another MVP, kind of Ginger Grant, about this, and she's like, no, all of my stuff is Spark because it's standard, it's easy, everyone understands it, right? But if you want to try and avoid Spark, the next big thing is Polar and DuckDB that I think Mim is going to be doing a talk later on, hopefully, right? And this also begs the next question that someone asked: how do you read files from OneLake storage in Fabric notebooks, right? So kind of two questions in one, right? Let's deal with the performance. This is a Python only notebook, right? So when you have a notebook, so just to show you this is a if I go to my workspace here, it's Fabric Dev, let's just go to one that extracts CSV, right? At the top of your notebook, you see it's generally a PySpark notebook, right? You can make a Python only notebook, and a Python only notebook, I think here's an example of a Python only notebook. If I just connect to that, oh no, that's actually PySpark as well, actually. I've got an example of Python only notebook somewhere. At the bottom, it will say 2 cores and 16 gigabytes of RAM, and it will show you more. So a Python only notebook potentially uses 8 times less resources than a Spark kind of notebook, right? And Polars then is an open source library that can read and write CSVs, Parquets, and lots of other formats and write to the Delta format. So for file IO, you can find that same thing that took 1 minute and 2 seconds on Spark took 36, so half the time. But that's not what's impressive. What's impressive is the fact the Python only notebook is only 2 cores, and the Spark had 16 cores because it had like because we had 8 cores for the controller and 8 core for the worker. So you got faster in less compute, right? The other thing that people are looking at is DuckDB. DuckDB has an interface where you can put a SQL-like language on top of reading Parquets and CSV files and Delta files as well. So if you've got a OneLake table, and that gives similar performance. Now, Mim has done a lot of benchmarks, and as you get more cores, sometimes DuckDB is better than Polars. But for me, the performance profile is as soon as you go to open source native libraries, because Spark is written in Java at the end of the day, right? So it's not the Java language is never going to be as fast as things like Rust and stuff like that, which is what the Delta writer is written in, right? So for lowering the compute, it does there. Does Spark use more compute than a pipeline, right? If you're firing a big job, it's probably equivalent, because behind the scenes, pipelines are kind of using Spark kind of like engines anyway. But for lots of small pieces of work, right? If you're only doing a tiny piece of work, spinning up a whole Spark cluster is probably more expensive. So that's probably the trade-off, right? But if you can use these new open source engines, you can really squeeze the most out of notebooks, right? So that makes sense. Now, to answer the question of how do you read from the filing system, there's 2 ways, and this is a great example, right? One of them is when you attach your default lakehouse. So if I just bring up a notebook, you will see you can attach a default lakehouse to your kind of notebook. So the notebook then has a local filing system. So there's this style of reference here, lakehouse default. There is a mount command where you can actually mount a file space into that as well, right? So anytime that you use any file command in PySpark, you generally tend to use the relative path here. There's also an absolute path here, which gives, it's kind of like a URL that you can use to access it. And if you've got a file, so say for example, I got a file here in my landing zone, you can actually get hold of the path for you. And if I just scroll down to the end here and just add a new, I think everybody does this in a demo, but I'll do it anyway. Load data, Spark. Oh, of course, it's a. Do they have support for Panda doing this? No, I'll have to get a CSV. It can be done in CSVs. Jason, surely I've got a CSV here somewhere. Ah, here we go. Right, the CSV. You'll see that it can write the code for you by using the relative pathing. So that's how you get to files, right? Answering the question of the metadata storage, fantastic question. I've got a whole session based on Fabric SQLDB, right? So basically within Fabric, you're perfectly right in that lakehouse tables are a horrible place to put metadata because the column store engine wants to have millions of rows and metadata is typically single rows, right? So when you're retrieving only a tiny piece of metadata, lots and lots as part of your orchestration, it's horrible performance. It's absolutely version 1. That's exactly what we did, but we used a data warehouse instead of a lakehouse for metadata because we wanted to access it by sort of T-SQL. But the performance of the data warehouse is exactly the same as the performance of the lakehouse, which is horrible for sort of metadata. It's also horrible for logging. If you're doing single row inserts, that's the worst possible type of pattern for Fabric because the Parquet files, so each row becomes a new Parquet file and the compression is absolutely horrible until optimization is done, right? So logging and metadata are two workloads you do not want to put in a lakehouse or a data warehouse. We recommend, although it's not in RTM yet, do you see here we have a SQL database that we called Meta. And within that, you can access that via SQL Management Studio. It does have a different connection string. So when you access it, you'll see the connection string is not the same as a connection string. What I typically do is in the register servers, another thing I hate is the fact that all the names have a GUID. So what I do is I put a user-friendly name in SQL Management Studio that I connect to, and this is now connecting to the SQLDB. This is where we store all of our clean metadata. We also put the logging information into the SQL database, which on hindsight, that was a bad idea. But for the metadata, it was a fantastic idea. And the improvement gains that we've had on some of the metadata activities have been massive, right? And you get all the benefits, such as you now have unique indexes, foreign keys, triggers, stuff that people working in a lakehouse or a data warehouse can only dream about, right? The SQL database then gets replicated to a lakehouse, right? So part of the product is when you put your metadata into a SQL database, you also get a SQL Analytics endpoint that is a lakehouse that use open mirroring to sort of keep that up to date. So that's a big recommendation, and a learning for us is SQLDB. It's not RTM yet, but we've been using the public preview and it's pretty good, right? There's just a couple of things missing. I've got a blog where I've listed like the top 10 things that are missing from kind of SQLDB. So watch out for that. Hopefully that answers the questions. Great question. PyODBC to access the SQLDB. Yeah. So one of my big complaints is the product team released a connector for Spark, the data warehouse connector that lets you do connect natively in a notebook to a data warehouse and potentially SQLDB, but it only supports tables and views. And generally, if you've got metadata, there's a bit of compiling of the data, and you tend to use stored procedures. So for us, we have a unit of work called a package group. So we call a stored procedure, pass in a package group, get a list of all of the notebooks and pipelines back. So it's got to be a stored procedure. So yes, absolutely, we use PyODBC. And one of the problems of using PyODBC is ODBC Fabric is authentication. So I've actually got a blog article on that about how to make that easier. You can actually call this command to get a token, slightly change it a bit, and it converts it from a Power BI token into a SQLDB token that you can use to connect to a SQLDB and a Fabric data warehouse. So I'll drop that into the chat there, right? So if you do want to use ODBC inside Notebook, that's strongly recommended. Right, any fantastic questions there?
So we have a couple of questions here. So the first one is, how do you read files from OneLake storage into Fabric notebooks?
Yes, so I've kind of answered that here. Like here, the source and the target with files that are on OneLake storage, right? The big thing to understand is that when you configure a lake house, right? So here's a lake house, kind of not quite a lake house explorer, but you'll see I've got the files area, which is my effectively OneLake, and I've got the tables section that is my structured files, right? So all you're going to be doing is copying your files from here to here. Now, there are various kind of wizards that actually do that for you. So you can right click and go, if it's a CSV, it will automatically mount that. But notebook wise, you have a parameter for the source. The target can just be the name of the table if you're using, if I just go back, can just be the name of the table if you're using Spark, right? And then that files is then the reference to the file on the OneLake for the attached lakehouse, right? And then in Spark, you're just going to put that in as a parameter. So there's my source here, and there's my target table that I'm writing to. So it's nice and clean, and there's lots of examples of that type of activity. Does that make sense? Was there another question there?
Yes, yeah. Another question was, question is from Abhay. And my biggest question is if we have multiple notebooks, which we put in a master orchestration data pipeline, just to have them in one place in series, each notebook uses its own Spark cluster and takes 2 to 4 minutes to start in F64. How can I ensure all notebooks are using common Spark cluster?
Yeah, so that's changed within the last few weeks, right? I'm assuming you're calling them from a pipeline, right? So you've got a pipeline that's kind of calling each kind of notebook, right? Yeah, so there's two ways of doing that, right? And I will be touching on some of the ways of doing that, right? The basic level, what you're going to want to do is turn on high concurrency mode, right? So if you go into workspace settings and then into your Spark settings, high concurrency mode, and allow multiple notebooks to share that, right? And then when you create a pipeline that actually launches a notebook, right? So if I just get a pipeline that launches a notebook, pipeline worker here. There's a switch statement that's going to launch a notebook, right? Notebook. So this is one that dynamically launches a notebook. In the settings, they added an extra, within the last year, an extra property called a session tag. And what that means is when you run the notebook, run it on this particular session. So what we do is we create a session tag called ETL and then kind of run everything on that, right? Or if you want to batch them, right? Now, the thing that changed is previously, up until a couple of weeks ago, even if you use that, it would still spawn a separate session when it was run from a pipeline. But if you ran it from a notebook by using the run multiple command, it would do that. Suddenly, without any blogs or me not seeing any release notes, the session tag started working a couple of weeks ago, where when we have a for loop that has 4 notebooks, they now all run on the same Spark session. But if you have more than 4, it will spin up an additional one. Now, I don't know if the 4 limit is hard coded, but that's kind of how it works. So for us at the moment, we can get from a pipeline 4 notebooks to run on the same Spark session.
Perfect.
And that's only fairly recently that started working, right? Okay, so
so just to be clear, so
yeah,
it's only going to work if it's in a for loop. If it's not in a for loop, and then we have just individual 3 notebooks in series connected to each other, like for example, one passes, then the second passes, and the third passes in terms of an execution, then it won't work.
No. If you did them individually, right? And they sort of didn't have a dependency, right? So if it's just all launched at the same time, right? As long as they have the same session tag. So do you see that parameter that I showed on screen of the session tag here?
Yeah.
So as long as, first of all, it's using the kind of session tag. Secondly, the workspace has got the high concurrency settings enabled here.
Yep.
Those are the 2 requirements for it to work, right? And this only started working for us 2 weeks ago, right? So give it a test. It should work. The other option is the run multiple thing, right? Okay.
Okay. Thank you.
Okay. Extracting from CSV then, which hits on the question of how to get files. This is how we would do it in ADF. So we would have a source and a sink on a copy activity. Python notebook is then very straightforward, right? This is the naive example, like 3 lines of code, right? But what we found, especially with CSVs, is we got greedy. We want to do so much more than just loading the CSV into a table. We found we wanted to do things like, if the folder structure isn't there, create it. We found that there's a lot of variety in CSVs, like quotes, escape characters, carry returns. Some of them don't have headers, and we want to inject headers into the CSVs. Some of them have a US date format, a UK date format, and we want that to automatically load as a date, right? So there's all manner of parameters, but we don't know what those parameters are when we're developing it. We just want them to work without us having to code. So what we did, and things like we want to be able to merge, so have a transactional CSV that someone gives us, just merge it into a lakehouse table, so all of history is there, and it just appends onto the end. And if we get a duplicate, it kind of merges. Do we want to dedupe? Say, for example, someone kind of gives us a CSV, but the same row is there twice, right? It's annoying to have to load it and then kind of dedupe. Why can't it just actually dedupe it as it loads it? So we wrote for CSVs, like, you know, on steroids, every possible feature that you could change by just putting the parameters in here, right? So in the source settings, you could put any parameter that was Spark approved, and what would happen is when it actually read the file, just get to the bit that actually reads the file here, there's a thing called packing in Python where you take the JSON and just throw it into the function so that the metadata just flows through without any unpacking. So it's very extensible, right? But then we can do things like clean all the headers for non-supported characters, add a checksum, delete any duplicates, add lineage columns, merge it. So all this advanced stuff, the extensibility of the notebook now blows away the pipeline completely, right? And it becomes a lot more kind of a usable tool because it's a template driven approach that although it takes more investment in time, we're going to use that template for years to come on lots of customer projects, right? So it's handy for us. An example in a notebook of where the complexity of APIs, we have a sample notebook that you can download if you want. It's here on GitHub, which will integrate with SharePoint. Now, SharePoint is a nasty graph API. And what we found is you had to make 7 different API calls because you got to authenticate, you've got to connect to the site, then to the document library. And if you want to do something fancy like a wildcard, star.xlsx, find me all spreadsheets and download them in one single command, you've got to use the API to enumerate all the files. So what we did is we developed a Python library, hid it in the built-in resources of the notebook, right? And the Python library then had all the complexity of the APIs and the calls for the graph API to SharePoint. But the actual notebook itself then became fairly straightforward. You can just say for every file name in the list of files on this kind of SharePoint site, write it to a lakehouse kind of table, right? So if you are integrating with kind of SharePoint, there's some starter code there that you can use to extract from SharePoint, right? That's that. Going beyond ADF, some stuff that's impossible almost to do in ADF, what we call a Frankenstein file. So here, this is from a retail system. A POS gives us a CSV, but it's 2 CSVs glued in one. There's a header line and a sales line, and there's no foreign key. The only reason that you know that that cell is for that header, sorry, that cell is for that header is because it's beneath it, right? So you couldn't split them into 2 tables, it wouldn't work, right? So to do that in a pipeline is almost impossible, right? But to do that in Python is very easy. You just loop over the rows. If it's a header, cache them. If it's a non-header, put all the header detail to sort of denormalize it or naturalize it, as they call it, write it out to a nice clean kind of table. So notebooks much better for those. JSON, you can do standard shredding where it just guesses. So there's a normalize function in Panda that will do that for you, or you can just do Python code. XML. XML is great in kind of notebooks because in notebooks you can use style sheets. So here with this third-party library, I can take any XML, pass in a style sheet, store it in the metadatabase, and I can use now. Nobody understands XLSTs, even really old kind of people like me, or writes them because they're really verbose. But you can go to Chat GPT and say, here's some XML, give me the XLST to generate this, and it will render it for you, and you can apply it. So dealing with unstructured kind of data is much easier in notebooks. Now, let's chat about orchestration, right? How are we on time? I know I did answer a couple of questions. Are you guys
we can keep going, Bob. Yeah, we're good.
Okay, so orchestration, right? This is what I call hard-coded orchestration. Imagine in ADFs, for small projects, you might do orchestration by each of these being a separate pipeline, right? And say, well, run that pipeline, then that one, or run that notebook, and then run that notebook, right? That's what I would call an anti-pattern for large projects, because you've now, anytime you change the orchestration, you've got to deploy code, right? So we 10 to 15 years ago, we switched to metadata-driven orchestration. So what we have is we have a pipelines table, a pipelines group table. Pipeline is a unique piece of work that could actually be a notebook, a data flow, a store procedure, or a pipeline, right? It's just called pipelines. And then a group is just a group of those activities with common kind of settings, right? And then a store procedure retrieves that. We put it into the SQLDB because of the metadata storage is better in the SQLDB. And we then, so that's step 1. Step 2 is we then parameterize everything that we write so it's reusable. And then we have this thing called a controller, and that's if it's an ADF pipeline or a Fabric pipeline or a notebook, they have standard parameters that we then have a worker that reads the metadata in a for loop, executes them in parallel, but only the ones that have the same sequence number, right? So we dynamically build the dependency. Now, in version 1, there was a switch statement, right? So the switch statement then was absolutely horrible because we had to have a different switch for every single notebook and every single pipeline. And we had to unpack the relevant parameters, right? And every pipeline had different parameters depending on what it was doing, right? So we realized a few years ago that this wasn't a scalable approach. So the first thing we did is we standardized all the parameters. So every notebook and every pipeline that we ever write has the same parameters: source settings, target settings, activity settings, source connection settings, target connection settings. And then the richness is expressed. So this is if it's a CSV. This is if it's a SharePoint site. This is if I'm reading from an SFTP site. And this is if I'm calling a stored procedure to export a CSV, right? They all use the same parameters, but in different ways. And then about a year ago, they upgraded Fabric, and we actually all had a beer at work after this came out. You can now do dynamic notebook and dynamic pipeline so that your orchestration can take the ID of the notebook or pipeline and execute it dynamically. So you can now just drop your sort of template into a folder and it just runs as part of your orchestration without any code changes, as long as the metadata's there, right? So this was a big thing for me, right? Now, the next thing is, though, we're still using ADF for orchestration, right? Because ADF is calling the stored procedure. Can we ditch ADF completely, right? And just use notebooks even for orchestration, right? So yes, kind of. What we did is there's this, it wasn't there in version 1 of Fabric, but I don't know when it came out, the concept of a DAG, right? So I think this comes from Airflow, and it's a way of providing a data structure that says activities and tasks. So you can dump all of your pipelines for your entire orchestration into a DAG structure that models the dependencies and which runs in parallel, and then use the run multiple command to actually do that. So that's exactly what I've done here. Is, do I have version? Oh no. Here. So this is a replacement for our last pipeline. Is what this does then is it uses ODBC to call the same stored procedure. So if you look at this, look at the, where's it gone? Pipeline worker. It's going to call the stored procedure, have a for loop. The for loop is going to have a switch statement to launch the piece of work, right? So here we call that exact same stored procedure, put it into a data frame, which gives us a list of all the pipelines they're going to run. And then we could run them sequentially, right? But it's not going to get that sort of parallel execution. So to get it to run in parallel is a little bit more work. We create a JSON structure, which is this kind of DAG. God bless Chat GPT for helping with the finer points of the syntax. But the end result is we get this kind of JSON structure. The run multiple command accepts as an input that actually DAG, and you can now get that when I run this, just run my thing, get my stored procedure, you'll find that now these will run in parallel. So I've got to wait for the notebook to spin up. It's now, there it goes. There's my metadata. This is now, there you go. See, it's queued. What you find is these are both going to run in parallel. So one of the notebooks, so this is calling one notebook to take a bunch of CSVs and load them into OneLake, and another notebook to go over to SharePoint, get some files and load them. So you can see they both kind of launched at the same time and they're running in parallel. So that's parallel orchestration. And for us, that's the last thing before we can completely ditch pipelines configure, is that final orchestration piece is what we were clinging onto pipelines for, right? Good news on can we get a copy? You can have a copy of everything that is here, right? So Fabric notebooks aren't quite there. Now, what's interesting is I did a similar talk about 6 months ago, and some of the stuff I asked for has been done. Other stuff that I've asked for, like a PySpark connector for sort of data warehouse, they've introduced it, but it doesn't work with stored procs. So I'm like, it's useless to me if it doesn't work with stored procs. But some things that will help us move to more notebook-centric is there's no concept of IR support. So at the moment, if you have on-premise kind of data, we have to use a pipeline in order to get hold of that. And identity is a bit of a mess. When you run a pipeline, it runs under the identity of the person that last saved it, which is like, I don't think that's a very secure way of doing it, right? It really needs the concept of a managed identity for notebooks, which is what we do have in the ADF world, right? So there are a few things that aren't quite there, right? So we're still using pipelines for these at the moment, but I'm looking at a strategy to use that DAG structure to replace orchestration to be completely notebook centric, because that coming in and out of notebooks is chewing up a lot of time, right? So I'd love to get rid of that. All right. To answer some of the other questions, can we get some of the samples and stuff like that? Right. So within here, we do have some samples here which will show some of the concepts, like how to connect to SharePoint. I've got a cool SP Who is Active program, which is like the SQL DB Engine one, but it runs on Fabric Data Warehouse and gives you what's kind of currently running and all information on it. The other thing is there is the entire data warehouse automation framework. We put the source code up. It's open source, right? So it's a framework for fully automating the building of data warehouses in kind of Fabric. Now, the documentation is work in progress, so we literally only started on the documentation for that. But if you go to the wiki site here, all the source code is in GitHub, and go to templates, you can see that you can get hold of a few. Now, we've actually got about 40 templates, but this is just the ones we managed to clean up, right? So extract CSV that you're asking for. This is our if you export this and import it, you'll get to the notebook that is the extract at CSV. So that's like the Swiss Army knife of it. A great question on the lineage key, very well kind of spotted. The lineage key, what we do is when we first get a piece of data, we get a random lineage key, and that gets put onto the data table at the as soon as it's in structured kind of storage, and the lineage key flows through to the star schema. So when we have in our star schema a lineage key, we can trace back to exactly what file that came from on the filing system, and some of the audit tables in the SQL DB actually store that. So yeah, when I go to the pipeline log, it would show me which lineage key was run by which process. But when I go to the data warehouse, I could go to a fact table, and each row would have a lineage key on it. So it's just a way of doing row lineage for that, right? So that's basically sorry for the little bit kind of rush, but there's a fair bit of content, some fantastic actually questions. I will put the links. Yeah, I think there's a link to the GitHub there, and there's a link to the DWA framework, which has just got, there's some sample templates, right? Even if you're not jumping in and writing a automation framework, right, you can certainly look at the templates to get an example of, I want to read from kind of SharePoint. Here's an out of the box template for reading from SharePoint.
Okay, so we have one question here, Bob. So Bohan Das, very loaded question, but does it make sense to migrate from on-prem SQL DB to Lakehouse plus notebook architecture if company has Fabric capacity and is using some of the Fabric features? And what are the benefits?
So this is where you've got a data warehouse in a SQL DB, is it? I'm assuming?
It just says, so he says only on-prem SQL DB.
Oh yeah. It's like a DB engine. Yeah. The answer, like everything, is it depends, right? I'm chatting to at least 10 customers on exactly that, right? The problem is, if, say, for example, you are using SSIS, right, and you've got, depending on whether it's imperative or declarative, if it's imperative and you've got hundreds of SSIS packages and lots of on-premising, the sheer cost of moving that is quite expensive, right? So a lot of our customers are not doing the big bang because it's like it's a massive project. What they're doing is Power BI is already in Fabric. If they have analysis services on premise, they're moving that in to Fabric, right? And then they considering using replication to get the star schema from on-premise to replicate that up into Fabric. So a piecemeal strategy rather than a big bang. Once you get your on-premise replicated into Fabric, you can then do AI projects in a sort of notebooks using your on-premise data, and all of your data is in the cloud, but the ETL is still on-premise, right? The ETL is the last thing to migrate because it's the most expensive, right? So that's kind of it.
Perfect.
Yeah, there's a good question there on using Fabric for ETL logging, right? Yes, we use the SQL DB for ETL logging, and we regret that deeply. Don't use it. For the reason is, if you go to the capacity metrics, and you would see this more on that, what we notice is that over half our compute unit was coming from the logging, because it writes it a row at a time, and the open mirroring uses a ton of compute. So we would recommend using, if you wanted to ETL logging, first of all, don't do it because the platform has a lot of logs anyway, right? So you can get natural logging on how pipelines are running. But if you need custom logging, consider log analytics, event house, or RTI streaming. That's what we're looking at the enterprise level. Obviously, if you're doing a smaller project, continue to use it, but do not use a lake house or a data warehouse for that, where one row at a time is arriving. It's an absolute killer, right? Oh, why not use a lakehouse and a warehouse for storing ETL metadata? So there's lots of reasons, right? One is ETL metadata is very small, and the column store engines are built for larger volumes. The main reason is the retrieval queries. What you'll notice is when you run a SQL query, like a stored procedure, to return one row, it's very slow in both lake houses and warehouses. Like the response time is going to be a second, whereas on a SQL DB, it could be 10 kind of milliseconds, right? So hundreds of times slower, right? The other is when you're writing metadata, we found developers would mess up. They'd put an entry in the pipelines table, but forget to put an entry in the pipeline groups table. Referential integrity was a massive thing for us, right? The other is we use JSON a lot. And one of the things that we have to do is we use inherited JSON, where you can specify JSON at one level, it go to another level, and then go to another level. So we have to parse it. And Fabric doesn't have full open JSON support. So SQLDB has full open JSON support. So and the performance was many times faster. So what we found is all those tiny calls to call the metadata and log it were disgustingly slow in Lakehouse and were really fast. So logging is much faster in the SQLDB because it's a single row insert in to a row store, so it goes from seconds per log to milliseconds per log, right? But the cost, because after it's logged it, every couple of minutes. Oh, Is there a question
when
there?
you
Sorry.
can mute. No, I think we
Oh,
just
right.
need
It was
to
just
mute.
there.
Yeah.
So hopefully that makes sense.
Okay. So Bob, I have a question. Parv, are you able to mute that person? Okay, Bob, so I have a question. I may have missed it. So in your architecture, do you use lakehouse, warehouse, or is it lakehouse all the way?
No, we actually use lakehouse, warehouse, right? But we have some customers who are using kind of lakehouse, right? Now I say lakehouse, warehouse because what we found is going back to the architecture here. In the classic medallion architecture, there's another lakehouse for the integration zone of the silver zone, right? What we found is 80% of the time we use a virtualized silver zone where we bring the information into a staging area, and that's absolutely a lakehouse, right? There's no choice on that, right? It's got to be a lakehouse, right?
Yeah.
But from there, we would use views, for example, right? And the views would then transform into the semantic model. So the silver layer doesn't physically exist, right? Unless it's a multi-step, right? So a lot of them are single steps. So for us, the silver layer became less and less important because for efficiency's sake, we'd go from bronze to gold in one hop, right? So therefore, we often just have two artifacts, a lakehouse and a warehouse. And we might have a couple of temporary tables in our warehouse, but kind of standing up a completely separate artifact when 90% of them are virtualized didn't make sense for us, right? But for other people. But with other customers now who want a lakehouse all the way through, so what we did is the loading generates dynamic SQL, and I've got a whole kind of session that I'm actually doing at bits on how to automate the loading of the star schema. So Kimball star schemas, how do I deal with surrogation, foreign keys, early arriving facts, all the good stuff, right? We then wrote a dynamic SQL that fully automates that. We then took that same kind of metadata and rewrote that in Python to generate it in Spark SQL.
Okay.
So we now support actually both because they all use the same metadata. It's just whether it's T-SQL or Spark SQL is the only difference, really, right?
Okay.
Yep, so there's a question there about transforming. I won't have time to go through that today, but I will drop you a link. I've done a couple of presentations on automating star schemas, and I'm presenting at SQL Bits. Here we go. Now, this is an old one. It's based on Synapse, but the concepts are exactly the same. There's no difference. It's just Fabric instead of Synapse, right? So that was for data toboggan. I did that for, right? And there is, I think, there's a 20-minute demo video of EDW automation framework with Synapse, Fabric DW. Oh yeah, Fabric DW and DWA. Yeah. So there's two bit of a, well, it's not really a sales pitch because I doubt any of you guys are going to come actually buying our kind of services as we're in we're actually in Ireland and everyone's all over the world, right? But if you click on that link, there's two videos there, and one of them, and if you go to the videos, there's videos in wine. One is the architecture behind kind of automation, and this is just our framework. I have chatted to lots of partners who've written their own frameworks, and they're fairly similar in kind of concepts, right? And then this is a demo of end-to-end, right? But there's another video I dropped is just talking about how we do the dynamic SQL aspect of the load and getting the SQL templates to be as dynamic as possible without having hard-coded SQL statements.
Okay. And then I guess one last question, Bob, before we close here. Did you see the materialized view announcement at FabCon? how do you see that, and how would that change your architecture pattern here?
It wouldn't change our architecture at all, right? So materialized views have been around for sort of 20 years, right? And they've always been a niche thing for doing certain activities, right? They were great for when you wanted something like a real, so say for example that you had a transaction table coming in and you wanted a real-time aggregate on top of that, you would create a materialized view, right? In the ETL world, materialized view, I don't see much demand in the projects that we have. Like, you can load into staging, you might have a view, right, that you use for your to do the transformation, right? If you materialize that, it just means your load is going to be slower. It's not going to help you with performance if you're only consuming it once as part of your ETL. The whole point of a materialized view for me is to have two tables synchronized that have different aggregation levels. So for data warehouse loading, no. But for other use cases, like say for example, you're using Direct Lake and you want to have an aggregate fact table, I think it could be fantastic for that type of use case. But for data warehousing, I suspect people are going to try it and it's going to be a mess.
Yep, makes sense.
Cool.
Awesome. Well, thank you so much, Bob. This was an awesome session. I learned a lot, and we can see from the reactions here in the chat as well. Everybody is very appreciative of everything that you have shared with us today.
Yeah. One last thing I just want to add before we go away. I just have this form. Ask people to fill that. There was one comment somebody left on the form, which tells everything, and it says, "Amazing. We need more sessions like this. I learned so much which I did not after attending few sessions in FabCon." So that tells everything. How great this session is. How much everybody learned from this.
That's me. Totally true.
That's you. Amazing. Thanks for the amazing feedback, and I really appreciate that. And thanks, Bob, for wow. This is awesome. Yeah, great.
Awesome. Thanks so much. If there's any follow-up questions, I'm always happy to shoot the breeze, especially if you're on social media. I'm extremely active on sort of data architecture, shooting the breeze on Fabric patterns, or sort of data warehousing patterns, or complaints and just moaning half the time, right?
Actually, I have a small question if you guys don't mind, just like 30 seconds. So in Fabric, we have something called monitoring, wherein it's basically logging every possible activity which is running in Fabric, but it only logs that metadata for 14 days. How can we extract that data and use it so that we don't have to implement our own logging using any method and just use what Fabric is doing itself?
Yeah. So what we do is, if you're using kind of log analytics, as you say, it only stores it for a short kind of period of time. So we wrote a notebook, 5 lines of Python code, downloads that data, merges it into a lakehouse table for permanent storage, and then you can keep your own login data for as long as you want to, right? And it's the same if you're going for Power BI log analytics, where you want to get the really detailed stuff in Power BI, like which kind of users clicked on a visual and kind of stuff like that. You can do exactly the same. It doesn't need a lot of notebook work to basically download it, stream it into a lakehouse for permanent storage. But out of the box, yeah, it is limited to only 30 days. I was speaking to Chris Webb on this, and I was saying, what do most of his customers do? And he say half of the customers just live with the limit, and kind of the other half are looking for solutions like I've just kind of said that we do.
Sweet. Okay, I'll check that out.
And then the workspace monitoring could also be an option. However, it is kind of expensive. So they mentioned at FabCon, they will be supporting in future all the workloads in Fabric. Currently, not everything is supported out of the box, but that's definitely one that I'm keeping an eye on.
Oh yeah, and there's one other thing. I'll try and find it. Have you heard, Fandip? Have you been following FUAM.
Yeah.
FUAM.
Mhm. Yep.
Yeah. So there's an open source project for a unified monitoring of Fabric that I've just put there. What they give you is an out of the box solution to basically download all the monitoring logs and lots of reports and accelerators on top of that. I haven't used it myself, but I looked at the sales pitch and I was like, wow, this looks pretty interesting. So I've just dropped
and
that link there.
they actually they merged it into Fabric Toolbox, which is maintained by the CAT team. So now, so it was developed by folks from Microsoft, but mostly from Microsoft Field. But now they've merged it into Fabric Toolbox, so which it is good that there is some kind of Microsoft backing there. It's so yeah, great. I'm actually have a project that I'm implementing this for one of my clients, but it looks great.
Yeah. Okay, fantastic.
Cool.
Thank you
so
so much
again, Bob. Really appreciate it. And in the future, I'm sure if all of us would like to have you back. So if you have a topic or a session that you would like to present, the door is always open for you.
Yeah. I mean, if you're interested in automating star kind of schemas, give us a shout.
Yeah.
Because we only really talked about kind of notebooks, which is really the E part of ETL, not really it's the sort of T and the L part, I think, are the most interesting parts, right?
Yeah. So when is SQL Bits?
SQL Bits is June, I think. June.
Yeah. Okay. Yeah. So maybe after SQL Bits, when you have time, we'll reach out to you and we'll schedule the session.
Great. Thanks a million. Cheers.
Thank you again. Bye-bye. Have a good night.
Thanks, everyone. Take care. Thank you.